Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through what we learned in week 1. So let's start with functions. So if you have an equation like y equals x plus 1, I want us to start thinking of this as a map. So what we have is a set of x values and we map those x values to y values. So for example, if we had x is equal to 0, it would map to y equals 1, x equals 1 gets mapped to 2, and so on like that. So if we had the equation x equals y squared, we can also see this as a map where we take an x value to corresponding y values. So here x equals 0 maps to y equals 0, but x equals 1 would map to minus 1 and 1 because 1 squared is 1, but minus 1 squared is also 1. And similarly, x equals 4 would map to minus 2 and 2. So the first map here is an example of a function, the second map is not. So the difference between these is that in this function, each x value mapped to only one y value, whereas over here we had some x values like 1 and 4 that map to more than one y value. So we call this first set of values, the x values, the domain, and we call the second set of values the range. The domain are the values that we input into the equation, and range is the output, the answers we get when we substitute into the equation. So a function is a map in which no element of the domain maps to more than one element of the range. The idea behind this is when it's a function, we only get one answer. Here in this equation, we substitute an x value, we only get one answer for the y value. Whereas here, if we substitute an x value, there is more than one answer for the y value. And we really love it in maths when there's only one answer. So a way that we can check this definition when given the graph is use the vertical line test. To use the vertical line test, you see, is it possible to draw a vertical line that hits the graph more than once? So for this first graph here, if I draw any vertical line, there, wherever, it will only hit the graph once. So that means that this is a function. Moreover, because there are no jumps or gaps in the graph, there's no value here that x can't take, we call this a continuous function. So we write its domain like this. This is the shorthand way of saying x can take any value, x such that x is a real number, and similarly for the range, y such that y is a real number. This just means x can take any value, y can take any value. Domain is the set of values x can take, range is the set of values y can take. So if I were to look at this graph here, it still passes the vertical line test. Any vertical line will never hit this graph more than once. Whether I draw it over here or over here, it never hits the graph more than once. Now this vertical line here only hits the graph once because the closed circle means we include that point as part of the graph, and the open circle means we do not include that point. So this line here only intersects the graph there. So because there is a jump in the function at this point here, we say this is a discontinuous function. It is discontinuous at the point where x equals 2. So if I want to write its domain, I write it like this. This says mathematically x is between and including minus 2 and 3. So x can be anywhere between minus 2 and 3, including all of those values. Now for the range, it's similar. Y is between minus 3 and 3, but y can't equal minus 3 because we don't include that point there. So that's why this is not a less than or equal to, but essentially says the same thing. Y is between minus 3 and 3, not including minus 3. So if we look at this last function here, it is not a function because it's possible for me to draw a vertical line like here or here that intersects the graph more than once. So this means it violates the definition here. There is an x value that is mapped to 1, 2 y values. Even if you only have one such x value that's mapped to more than one y value, that's enough to say that it is not a function. All right, let's now look at some linear relations. So if I'm asked to find the midpoint of a line segment joining 2 points, it's actually very simple. My answer is a point, so I need an x value and a y value. So I just add the two x values together and divide by 2, and then I add the two y values together and divide by 2. You need to do this calculation separately on your calculator. So putting it on my calculator, I get this point here. It doesn't matter if the point is not a whole number, but all I've really done is find halfway between the two x values, halfway between the two y values. So let's look at this question here. So this time I'm told the midpoint, and given one of the endpoints, I need to find the other endpoint. So this is what I have. A, M for midpoint, and I need to find B. So B is going to have an x value and a y value. So for the x value, 4 will have to be between 3 and this x value. So I've added 1 here, so I'm going to have to add 1 again, and the x value will be 5 because 4 is halfway between 3 and 5. So similarly, to go from 5 to minus 2, I actually subtract 7. So I need to subtract 7 again. I get minus 9 because minus 2 is halfway between 5 and minus 9. So this is the coordinates of B. Let's now quickly look at finding the equation of a line. See, any line except a perfectly vertical one can be written in the form y equals mx plus b. So to find its equation, we simply need to find m using the 2-point formula, and then we find b by substituting mx and y into the equation y equals mx plus b. So let's look at this example here. So if I want to find the equation, first I need to find m. So I go y2 minus y1 over x2 minus x1. So putting that in my calculator, I get 2 over 8 or a quarter. So now what I do is I take my equation y equals mx plus b. So I'm going to substitute m for a quarter, which I just calculated. And then I'm going to substitute x and y. So x and y come from one of the points. It doesn't matter which one. So in this case, 4 is easier because they're both positive. So I'm going to substitute x for 4, y for 4. So I get 4 equals 1 plus b, subtract 1 from both sides, b is 3. So my final equation is y equals mx plus b. All right, let's now have a look at how we would graph a line like this. So to graph the line y equals a quarter x plus 3, we'd use the gradient intercept method because it's in the form y equals mx plus b. So when it's in that form where y is the subject, m, the number in front of x, is the gradient, and b, the number by itself, is the y-intercept. So this line here has y-intercept 3, gradient a quarter. So the way we're going to graph it, firstly we're going to mark b, which is the y-intercept of 3, so that's there. Now we're going to use the gradient to find a second point. The gradient is rise over run. This number in the bottom tells you how far you go right, always go right. This tells you how far you go up or down. Positive you go up, negative you go down. So I'm going to start at my y-intercept of 3. I'm going to go across 4 because the run is 4, which leaves me over here. And I'm going to go up 1 because the rise is 1. So now that I've got the 2 points that lie on the line, I simply join them up. So that's the first one done. Now let's look at this one here. 2x minus 3y equals 6. It's not in the form y equals mx plus b. We can't see from this easily what the gradient is. It's not 2 because it's not in the form y equals mx plus b. So when it's not in the form y equals mx plus b, use the xy intercept method. You let x equal 0 to find the y-intercept, let y equal 0 to find the x-intercept, and join them up. So if I were to let x equal 0, I'd get minus 3y equals 6, y equals minus 2. The y-intercept is minus 2. If I let y equals 0, this is 0, I get 2x equals 6, x equals 3. So the x-intercept is 3. So now that I've plotted both of the intercepts, I simply join them up and then I'm done. All right, final topic, let's look at parallel and perpendicular lines. So 2 lines are parallel if their gradients are equal, 2 lines are perpendicular if their gradients multiply to minus 1. So if I have a line like this, I can't read off its gradient easily. In order to calculate the gradient of this line, I need to rearrange it in the form y equals mx plus b. So to do that here, I'm going to subtract 2x from both sides and then divide by minus 3. So I've got to divide everything by minus 3. 6 divide minus 3, and then minus 2 divided by 3. So the gradient of this line here is actually 2/3. I can read off the gradient now. It's in the form y equals mx plus b. Gradient is just the number in front of x. So what would be the value of k in this line if the two lines firstly were parallel? Well, let's do the same thing here to find the gradient of this line. See, here I would do something similar. I would subtract kx from both sides, and then to get y by itself, I'd divide by 6. Divide everything by 6. 12 divided by 6, and then k divided by 6. So the gradient of this line here is k over 6, whereas the gradient of the first line was positive 2/3. So if these two lines were parallel, then their two gradients would be equal. So the gradient of the first would equal the gradient of the second. I can solve this equation really easily. I just undo what's been done to k, times each side by 6. I get k is equal to 4. So if k is equal to 4, these two lines are parallel. What about perpendicular? Well, if perpendicular, then their gradients must multiply to give -1. So we can solve this easily. We can divide by 2/3. So then I would get k over 6 equals -3 over 2. Now I'm simply going to times each side by 6. I get k is -9. So if this number here were -9, then the two lines would be perpendicular because their gradients would multiply to -1. All right, thank you so much for tuning into this video. Keep your head up. You're doing really well. This has been the luckiest maths teacher in the world. Have a great day.